Hello, geometry students. Mr. Alent here. Gonna go over our 10-5 notes here. So we're finding the surface area of pyramids and cones, right? Last week we did surface area for prisms and cylinders. Now we're looking at pyramids and cones. And a couple of new vocab terms we need to be able to do this. Are something called the slant height. The slant height you have to be very careful with. It's easily mistaken or misconstrued. Slant height. So on this cone here, the slant height is actually this kind of edge length right there, and we denote it in our formulas with like this kind of cursive L. Right. So slant height is L. Okay, and so a slant height on a cone is there. On the pyramid, now this is where you have to be really careful on the pyramid. It goes from the vertex down to one of the base edges at a perpendicular, right? So this guy right here is the slant height for the pyramid. So slant height, that's a really necessary piece to be able to get our surface area for pyramids and cones. We also need something called the altitude. The altitude is more commonly thought of as the height, right? So we're going to use h to talk about that. The perpendicular distance from the vertex to the plane that is the base. And so on the cone, this is your altitude, or height if you will. And then here on the pyramid, there is your altitude or height. Okay, and because you can see here in the formulas, right, for our pyramid formulas, and again, we're going to talk about lateral area and surface area. Remember, the lateral area is the area of everything that's not the base or bases, right? In this case, with a cone and pyramid, there is just one base. So this is the lateral area of the surface that's not the base. Then the total surface area is that lateral area again, plus that base area added in, right? So again, L stands for slant height. That capital B stands for the area of the base, and again, that can change, right? For the cone, the area is the base is a circle. For the pyramid in this picture, it's a rectangle. But remember, there are other pyramids too. There are octagonal pyramids, there are pentagonal pyramids, square pyramids. There's a whole lot of different bases, and so capital B just stands for the area of whatever that base is. Okay, so capital B, base area. So let's see an example here. We have, oh, and by the way, one last thing I want to say too, actually back up there at this picture. You can see with both of these that they kind of, there's this like little line right here, kind of completing this triangle. So you can imagine we might use some triangle stuff to try to find H and L maybe at times in problems. Same thing here, if I were to kind of connect the dots to there with the slant height and the altitude, and then with this new length here, which by the way, that length is half of this base edge if we're talking about a rectangular base. I've created this right triangle right here, and we could talk about maybe Pythagorean theorem or some trig to find some missing pieces or sides. So please note those triangles. Okay, so here's an example. We're going to find the lateral area. This is a hexagonal pyramid, right? We've got a hexagon base with a pyramid. We've got all these triangles coming up to a common vertex off of the base. And we've already put in the picture here, here's the slant height, but notice something. We don't know it. We don't know the slant height, and in our formula we need it. There's our cursive L, right? So we need slant height. We don't have it. We're going to have to do some work to find it. We do have this light here, and it's called the edge length. This edge length is 26. The slant height is not 26. The edge length is 26. They are not the same. Remember, this is slant height is coming down, and it's coming at a right angle into this side, and so we are creating these little triangles. The little A here, that stands for apothem. We're going to need that later as we find the area of that hexagon base, and so that's the apothem of the hexagon. We don't need that right now for the lateral area, but we'll need that for the surface area. So let's kind of take this triangle right here, and maybe I'll highlight it. We're going to take this triangle right here, and we're going to redraw it, kind of fill in the information. All right, so I'm talking about that triangle there. Let's just redraw it real quick. and fill in the information. So again, we had the edge length as 26, and notice where that is. Here's the right angle, edge length is crossed, so the edge length is the hypotenuse of this guy. So that's the 26. The slant height is what we don't know but we want, so that's our L. So I'm just going to call it L. That's what we need to find, slant height. And then if you look, the base edges of our hexagon are 20 feet. And when the slant height comes down, it does bisect that side. So this little piece here is going to be half of the 20. It's going to be 10. Okay, so this piece is half of the edge. The edge is 20, half of 20 is 10. So now we have a Pythagorean theorem situation, right? I've got one side I need to find, but I know the other two sides of a right triangle. Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. So L squared plus 10 squared equals 26 squared, and then we'll find our L. So go ahead and do the work here, right? We're going to square those out. So L squared plus 100. 26 squared is 676. All right, then we'll subtract 100 from both sides. Right, we're solving for L. So L squared is going to give us 576. And then if you remember from here, to get L equals, right, we don't want L squared, we just want L. This is where we have to then square root both sides. Like that. Square root of 576 is 24. So our edge length, or excuse me, our slant height is 24 feet. So looking at the formula here, lateral area is 1/2 times, now capital P stands for the perimeter of the base, just like it did in the other formulas for prisms and cylinders. Well, cylinders not necessarily, but prisms. And so we're going to just get the perimeter of our base. Well, there's 6 sides, all of them are 20, right? So our perimeter, we have 6 sides, all of them are 20 feet. 6 times 20 is 120. So there's our perimeter. So now we are ready to put in our formula for lateral area. So lateral area is 1/2 P times L. That's going to be 1/2 times 120 times L, which was 24. 1/2 times 120 times 24 gets us a lateral area of 1,440 square feet, right? It's an area, so it is square feet. So there's our lateral area. Okay. All right, so let's move on to surface area. So getting the surface area, we're going to, let me write the formula out real quick. Surface area is 1/2 PL plus capital B. But again, 1/2 PL, that is lateral area. That's what we just found, right? 1/2 PL. So we already know that. It's the 1440. We just need to add in capital B. We got to find what capital B is. Okay, well, remember, capital B stands for the area of the base, right? And right now, the cap of the base is the area of the hexagon, right? The hexagon is the base, so the area of the hexagon is our base. And to find the area of the hexagon, we do 1/2 times the perimeter times the apothem, right? This is back to last chapter, so keep those notes handy. 1/2 times perimeter. Now, the perimeter is nice. We already found it, the 120. The apothem was given, so not a lot of work here, right? We didn't have to, last chapter we had to find apothem or find sides or find perimeter. This time we're going to be a little bit nicer to you. We're giving you the information you need. So 1/2 times the perimeter of 120 times this apothem of 17.3 will get us the area of this hexagon, which is our base area. 1/2 times 120 times 17.3 is 1,038 square feet. Okay, but that's going to again go into our formula right here. So we're going to plug in the 1,038, add those up, and we'll have our surface area of 2,478 square feet. And there you go. So there's finding the lateral area and surface area of a pyramid. Let's look at a cone. So turn the page to our last little bit of notes for the chapter 10A. We kind of broke chapter 10 into 2 parts. So 10A, we have our test this week on 10A, which is just doing the area, the surface areas of these. Well, first identifying, right? So identifying, if you remember the solid geometry, identifying what they are, and then we did surface area for prisms and cylinders, and now we're doing surface area for pyramids and cones. Okay. Formula, a little bit different, looks right, but because it's dealing with circles. Cones deal with a circular base, and so we are going to see a pi RL. The lateral area, pi times R times L. L is, again, that slant height, which in this picture, we don't see it, right? We don't have our slant height. I mean, we can see it right here, but we don't have it. All right, so if that's our L, maybe I'll write into that. Like that. There's our L. So we're going to have to get the lateral pi times R times L. Remember, R is the radius of the circular base. R is the radius of the circle. L is the slant height. So we got the radius. That's 7. Here's R right here. There's our R. We just need to find what L is. And if you notice, again, look at the triangle. Looks like I've got the altitude. I've got the radius. I need to find L. That is a perfect Pythagorean theorem problem again. The lateral area formula is pi times R times L. So if we're kind of plugging in what we know right now, well, pi is still there. It's just that number, 3.14, right? Times 7. And then we'll have to fill in L in a second when we find it. So let's go ahead and get that. Again, Pythagorean theorem, right? So leg squared plus leg squared equals hypotenuse squared. L is the hypotenuse now. So the 7 squared plus the 24 squared is going to equal our L squared. Square those and add them up. That'll give us a 49 plus, what's the 24 squared is 576 equals L squared. Add those up. You get 625. Is our L squared, and again, though we want L, not L squared, square root both sides. And square root of 625 is 25. So the slant height here is 25 centimeters, and we can now plug that in to our formula. Okay, so lateral area, when I multiply 7 times 25 times pi, this will be 175 pi if we leave it in terms of pi, centimeters squared, or if we don't, if we round to the nearest tenth, that'd be 549.8 square centimeters. And again, just follow directions. If it says leave it in terms of pi, so this is in terms of pi, then that's what it means. It means just multiply the two numbers and know that the pi is still multiplying and it's there. If it says round to the nearest tenth, right, so this is to the nearest tenth, then it means go ahead and multiply that pi in there. Use the pi button on your calculator. It's the best way to go, to the nearest tenth. Okay, and now let's find that surface area. I need to go a little bit quick. I got a minute and a half here. Surface area is pi RL, lateral area, that's what we just found, times pi R squared, area of your base, right? Notice it doesn't say capital B up here. It doesn't say capital B because it's a cone. It's always a circle. It's got to be a circle to be the base for a cone. So the area of a circle is pi R squared. The nice thing is you just need the radius, so we have all the information we need. So we're just going to plug it all in. Surface area is pi RL, and I'll use the, in terms of pi, the 175 pi plus, and again, that came from up above. We just did the pi RL, plus pi times that radius squared. So 175 pi plus 7 squared is 49. That's a 49 pi. Adding those up, you're going to get 224 pi. Or, and again, centimeters squared. Or, if we had the decimal to the nearest tenth, 703.7 square centimeters. So same story, follow directions. If it says in terms of pi, stop there. If it says to the nearest tenth, then multiply that pi in there and get that rounded number. There you go, guys. That's our Chapter 10, Section 5. That ends our Chapter 10, Part A. And so good luck on this week. We'll talk to you guys later.